Well, hello and welcome YouTube to Mr. Robinson's Q&A Power Hour. This is the first one of this year that I'm doing for my students here, and this is for my Integrated Math 2 group who've been focusing on interval notation, intervals of functions and curves, and where they're positive, negative, increasing, decreasing, where the zeros are, average rate of change, little different things like that involving intervals, and then absolute value functions, how to graph them, and so far how to solve them algebraically and graphically. And then later, I think in the next day well, no, I already have the video up, but you are going to probably get some more questions from my students or whatever, some review at some point about solving absolute value inequalities graphically and algebraically, as they will actually be taking an exam at the end of this week here, and this is on the weekend before, so thank you so much for joining. I only have 8 questions with this. Now, here's what a power hour is. I want to dedicate generally an hour to a weekend where I answer my students' questions if they have them. Now, I only have, I believe, 8 questions covered. Yeah, just 8 questions here. I've only copied and pasted them. I like to spontaneously read them as they go, so we'll see what kinds of errors and stuff they have for spelling mistakes along the way, or if I can make sense of the questions that they ask. But I do have graph axes ready just in case, because we are talking about absolute value functions, if I need to give any examples of certain things. And they ask, I answer in the order that the questions were received, and then we move on from there. They get some credit for asking questions that are content specific, that are more broad, though, in the sense that they're using their academic vocabulary and things like that. And generally, I like for them to follow up these questions and answering them for themselves, especially if they ask the question for themselves. That's an assignment for them, though. Let's go through these questions here. And hopefully, what I was able to already do when I got this thing published was put in the description section down below each question and the timestamp when it is asked and answered. So let's go ahead and get started and take a look at what questions they have for me here. And the first question that is asked is, how do you know on a graph if it's going up and down using the equation? My guess is because us dealing with equations was only in the absolute value stuff. I'm guessing that's what they're asking about, absolute value equations. How do you know on a graph if it's going up and down? I assume they mean up or down, in which case I mean if it's faced up, V-shape faced up, or V-shape face down right there. So the way to answer this best is really to look at the vertex form of an absolute value equation. So I'm going to go ahead and write that out for you guys here. That's going to be f of x equals a times the absolute value of x minus h plus k. And I'm sure this isn't the last time that I'm going to be visiting this formula here. So what this formula here is, it's the vertex form of an absolute value function where the vertex appears at the coordinate pair h comma k. That's the lowest or highest point of an absolute value function. And then a is known as your stretch factor. Stretch factor is a, where it's really I'll put VSF. It's a vertical stretch factor. It shows how high or how low your graph is going to stretch compared to that of a normal up 1 over 1 graph. If a is 2, it's going to be twice as tall. Rise 2, run 1 instead. Now, everything else is based on a as well. With your a value, you can also know based on its sign whether the graph will face upward or downward. If your a value is a positive number, our way of saying that is if a is greater than 0, then you have an upward facing V-shaped graph. And if a is less than 0, if a is a negative value, then you have an upside down V-shaped graph like that. And those are really your only 2 instructions to that thing. Now, you do have to make sure that you are in vertex form for that to occur, meaning you have to make sure that there's nothing that's in front of x except for just a positive 1, right? And then if you can't see an a value, then that must mean it is a 1, right? If you can't see it, it must be an a. Or if it's a negative sign, that means it's a negative 1. Just make sure you know that. But the only thing you're looking for whether it's facing up or down is whether it's positive or negative. Now, if you ask, what if a is 0? A can't be 0, because if it's 0, that means it multiplies by the absolute value of things with x in it, and this goes away, and no longer do you have an absolute value function. Now you just have a constant function. So a is either positive or negative, and again, if it's positive, it faces up. If it's negative, it faces down. Just kind of recapping that over and over, because I want to make sure that that's really reinforced and it makes a lot of sense for you. All right, there's the first question. The next question asks, when doing interval notations, this was kind of a little bit ago, how can you tell when to use parenthesis or brackets? And parentheses or square brackets, right? So what they're talking about here, interval notation let's see. Let me go back to this thing here. Give me one moment. I'm going to duplicate this so I have that other page. Okay, interval notation is just another way of writing inequalities as far as literally how far left or right your solutions go, your x values, your y, whatever it is that you're talking about. And I like to always use a number line graph to give me the tie-in between what happens with inequalities and what happens with interval notation. So if I use an inequality such as something like x is greater than 9, we know that on a number line, that means that if this is 0 and this is 9, here are all the numbers that are greater than 9. So what we do is we construct 9 as a boundary point with an open circle because 9 is not included, and then we go ahead and we draw an arrow that way and say, hey, these are all the values that x can be. It can be 10 and 11 and 12 and 10.5 and 1,000 and going toward infinity. And so the interval notation aspect of this, when we write out interval notation, it gives us two numbers, left lower bound and right upper bound, meaning the lowest our values go and the highest our values go. If you look at the number line, you can tell that 9 is the lowest that it goes, and it goes all the way toward positive infinity. It never actually stops. That's the first part of interval notation, left lower bound, right upper bound. The other part is whether we use parenthesis here or a square bracket here and parenthesis here or a square bracket here. And so back to our question, when doing interval notation, how can you tell when to use parentheses or square brackets? Parentheses are used when we do not include, when we exclude our bounds, meaning that point doesn't count, meaning it's not satisfied with it. 9 doesn't count. 9, x cannot be 9. X needs to be greater than 9. That's why we put an open circle here. That's why we didn't put this little line thingy here. And when we exclude 9, we want to put a parenthesis next to its lower bound. 9's the lower bound, but 9's not included. That's the way interval notation is expressed there. The upper bound is positive infinity, and because infinity is not a value, we can never reach it. We never include things on infinities. So if you're going to ask with regard to infinities, we always put a parenthesis because we exclude it. We just never actually reach it. And that's kind of a way of saying, like, I'm trying to catch you. I can't actually get you, but I keep going toward you over and over. Now, on the flip side of this, let's say that it said x is greater than or equal to 9. Well, the number line version of this would have closed the circle up because now 9 is allowed to be used. X is greater than 9 or x is equal to 9. And now, in this case, we talk about square brackets because square brackets mean we include the value. So inclusive means that the value can be used. So around 9, we say, since 9 can be included, we put a square bracket on that guy and say there's that. Now, we don't just automatically use two square brackets. Around the infinity here, we still can't reach it, so we still give it a parenthesis for that very reason that it's not included. So, bottom line, you use inclusive when we're talking about some sort of less than or equal to, greater than or equal to, the equal tos, and use exclusive when it's a less than or greater than. When it comes to that boundary value, again, that specific boundary value, we include the 9, we don't include the infinity, and you can tell that that's how it's written. Now, the inequality version of this didn't have infinity written because it wasn't written as a compound inequality. You have to be okay with the fact they sometimes aren't written that way. I guess ideally we could have written this as this. This would have been an equivalent of that. So you will see some compound inequality problems. Let's use one just with this number line here. Let's go from 0 to 9. 0 to 9. And this time I'm going to not include 0, and I'll still include the 9. So when I write this in interval notation, let's look at the number line with it as well. When I write this in interval notation here, think of how the number line would have this thing graphed here. We would be in between 0 and 9. 0 would have an open circle, 9 would have a closed circle because 0 is not included and 9 is included, and x would be any number in between where 9 is allowed. So the interval notation version, and I know I'm answering more than just your question, but I imagine that unless someone else asks the kind of question like how do you write interval notation and stuff, I imagine it's something good that we can talk about here. So 0 is now the lower bound, right? 0 is the lower bound, 9 is the upper bound. 0 is not included, it's excluded, therefore, because the less than, we use a parenthesis around 0, and 9 is included because 9 is a value that it can be, so we include it and we put a square bracket. And that would be the interval notation of that. So that's how those things work, guys. That's the idea behind it. You just, square bracket means included, parenthesis means not included, and you got to put it on the bound that you're referring to infinity or negative infinity are never included. So we always put a parenthesis on those. All right, so that ought to do it for that question there. It knocks that one down. And the next question will ask, I do not understand how to figure out the x's you put on the number lines for 2.2. All right, 2.2, guys, is in reference to the section that we were doing. That was, I don't want to mess this up. I think it's our most recent one, solving absolute value equations. So let's see. I don't understand how to figure out the x's you put on the number line. So yeah, very simple. So like I'm doing number lines right now from this previous problem here. Although these are with inequalities, and inequalities come next for my students in particular. There's a video already on solving absolute value inequalities. If you want to look at it, you can see how I graph them. But all we're doing, guys, it's the easiest thing you'll ever do in this class. I promise you. I know we didn't really do notes on it because I said it's better left unsaid. But if you have a number line here, I'm going to add a few more points. 1, 2, 3. You just place a point on whatever your solution is. So if my solutions that I get are x equals -2 or x equals 1, like that, when we solve an absolute value equation, we actually get these solutions. They say plot in a number line, plot a closed circle on -2, plot a closed circle on 1. That's it. That's it. I think it's just their way of going back to the fact that, hey, these are solutions, and when we get to the inequalities, we're going to have to start drawing arrows. But that's it for here on a number line. If it's a no solution case, because we are running into some of those, if it's a no solution case, how do you plot a no solution case? If the points indicate what solutions are, and if you have no solution, you don't plot anything. You just leave it blank. Because there are no solutions, you don't plot anything. Eventually, we're going to get some all real numbers cases for the inequalities. I know that doesn't have to do with this. But if you do all real numbers, just do arrow left and right on your x. X could be anything. That's not a no solution, by the way. No solution, you just don't plot anything. And there's the answer. All right, I hope that one made sense. That's the easiest thing I can say. You just plot the number on the number line where it is. Make sure that you get the correct answer and it can fit. And then that's it. All right, fourth question here. How do you solve a problem, algebraic, that doesn't have a k value, absolute value of 2x equals 9? I don't like when they give examples, but I could probably use it. At least there was a question. How do you solve a problem? Okay, so what they're talking about here, let's go back to this here. So remember, in the vertex form of a quadratic function here, k is a letter that's used here. It has to do with the y value of the vertex, but we're talking about solving algebraically. The point is, when we've been looking at equations to solve, we've had some sort of vertex form of an absolute value equation on the left side, and on the right side, we've just had some sort of constant. I'll just call it c. And we've been solving for x with it. So, for example, it could be 3 times the absolute value of x minus 7 plus 2 equals, 11. And then you kind of solve from there. The way that we would solve here is we would isolate the absolute value quantity right there. We'd subtract 2 from both sides, divide by 3 from both sides, and then you have it, and then you create 2 conditions, blah, blah, blah. There are videos on that. Their question is, what happens if this k value is not there? Like if k is 0, if the plus 2 is gone, and you have to solve that. Or their example, which I'll go ahead and solve with them too, but their thing right here. Kind of weird to say, this is an easier problem than if the plus 2 was there, because the plus 2 just means there's an extra step added. You got to first subtract 2 from both sides before you divide both sides by 3. If the plus 2 is not there, you just divide both sides by 3. Your goal is to isolate your absolute value quantity. The k is extra information. That's one more step you'd have to do. If the k is not there, that's one less step then you'd have to do. So in your particular example that you're asking, and by the way, your answer is going to have a fraction. I hope that's okay. The absolute value of 2x equals 9. Good news is your absolute value quantity is already isolated. You already have the bars as the only thing on the left side of this equation. So now you create your 2 conditions. There's no, your plus k, your plus 3 right here, you'd have to subtract 3 from both sides in order to isolate it. K is not there. There's nothing to isolate. It's already isolated. So to answer it, you do less work. It's a good thing. You do less work, but you'd get, 2x equals 9 or 2x equals -9. I'm not going to get deep into why that is. You didn't ask about that. Divide by 2, you get x is 9 over 2, or 4.5. And divide by 2, you get x equals -9 over 2, or -4.5. And then you're done. The k value is just an added step. K is just a constant that says that you have to subtract or add something to both sides of the equation to further isolate your absolute value quantity. So I hope that that helps, that it's actually easier that you don't have a k value there, or if you don't have an h or an a value or whatever it is. All right, 4 more questions. Here we go. How do you find the range on the graph, and why is domain always going to be all real numbers? Okay, those are 2 questions. The second question to answer is domain is not always all real numbers. If you're talking about what I've been bringing up and when we've been graphing absolute value functions, the domain's all real numbers. Why is domain all real numbers? Yeah, let's answer that first. Why is domain all real numbers for most equations? Domain is in reference to how far left and right our graph goes. And how far left and right our graph goes is based on what values of x exist on our graphs. So if we're talking about what values exist on our graphs, hold on, give me 1 sec. There's something vibrating here. Sorry, my phone was doing something. All right, so if we're talking about what values exist on our graphs here, what x values exist in our graph, you look at your equation and you ask, is there a restriction on what I can substitute for x? If I have an equation, I don't care what the equation is right now, just kind of think of equations that you've seen before. Is there a reason why I can't plug in a certain number for x and not compute this thing? For the majority of equations that you see, there's going to be no restriction. This includes absolute value functions. No matter what I substitute for x, I'm going to get a value out for y, and that's another point on my graph. That's why our absolute value functions have all real number domains. So when I go to, and I'm going to make one up, I think, well, let's do the one that I just did from the previous example. I said 3 times the absolute value of x minus 7 plus 2. Can I plug in 0 for x, 1 for x, 100 for x, and a billion for x? Yeah, I could just subtract 7, take, all that kind of stuff. There's nothing wrong with it. Negative 20, negative pi, negative square root of, 19. Yeah, there's nothing wrong with substituting those values for x. It's all real numbers. The graph goes forever left and right. The reason domain's all real numbers is because it goes forever left and right. Now, this goes beyond what we need to really talk about here, but there are kinds of equations where there are some values for x that you can't sometimes plug in. Let's give a basic example of like the square root of x. I can plug in any positive number. They're not all perfect squares, but I can plug in any positive number. Negative numbers, I can't take the square root of negative 2 and get a real value for y out that is graphable. So, there are negative, the restrictions here, the domain says x has to be greater than or equal to 0. I can take the square root of 0 and anything greater. I can't take the square root of any of the other ones. Another common example that you'd see is something like this, 2 divided by x, or whatever can be there. You can plug in any, I can do 2 divided by 1, 2 divided by 7, 2 divided by 20, 2 divided by negative, 14. But I can't do 2 divided by 0. You can't divide by 0. So the domain here says that x can be any value in the world but 0. Say x is not equal to 0. Those are examples of domain restrictions. Granted, this goes forever left and right on this one. It just can't be 0. And then this one here goes forever right. It doesn't go forever left. So our graphs go forever and left and right because there are no restrictions. Our domain is all real numbers for absolute value functions because the graphs go forever left and right. They go forever left and right because there are no restrictions on what I can substitute for x. There's no problem with computing whatever I plug in for x. Now your first question, what was it? How do you find range on the graph? Well, again, we're probably talking about absolute value. You might be asking in general. Let me just talk about the in general thing. The in general how to find range on a graph is you ask yourself, what is the absolute maximum and minimum that your graph ever goes in terms of height? How high does it go? How low does it go? So if you have a graph that, say, that starts, here, let me pull out this graph thing. Say that you have a graph that starts off right here and it goes up and down and back up again like that. The range is how low it goes and how high it goes, and you have to express that either in interval notation or in terms of y. This goes as low as 1, 2, 3, 4, 5, as negative 6 on y, and it goes as high as 1, 2, 3. So that's the range. How low does it go? How high does it go? You can write it in that way, in interval notation, whatever it is, and you're just, that's how your range works. It can be all real numbers if it goes forever down and forever up. And if we're talking about absolute value functions, and you might be talking about them because you asked about domain being all real numbers. If you're talking about absolute value functions, although they go forever left and right, they don't go forever up and down because of that nature of the V-shape of the vertex. When it hits a vertex, let's do this. When it hits a vertex like this one right here, it bottoms out. There is a low point to this thing. It has an absolute minimum. It has a minimum of, in this case, negative 4. because that's as low as it goes. So my range in that case is y is greater than or equal to -4, because it says the lowest I go is -4, and it goes up forever from that. Those are the y values that exist on my graph. X's go forever left and right, y bottoms out at -4 and goes up from there. So your range aspect just says what is the absolute minimum, what is the absolute maximum when it comes to vertex, and you go from there. That is a right side up graph, and an upside down graph might say, if you go this way, we'd say y is less than or equal to -4, because -4 is the largest y value that you get. So it's really just about how high and how low it goes. It can go up and down. Absolute value graphs can't go up and down forever, but graphs can go up and down forever, in which case we can say all real numbers. Otherwise, we use that, where's the vertex? And we talk about the range being y is greater than or equal to k, y is less than or equal to k, because k is the y value of your vertex in vertex form. All right, there's the answer to that question. Let's do 3 more here. Next one. What would the equation look like if we were to graph an absolute value function, but it was sideways? Like instead of a v or an a less than or greater than? Okay, v is v-shape, a. Are you trying to do like an upside down v? Oh, that's not less than or greater than. Sideways. I read the question first and I interpret it second. So they're asking, what would the equation look like? Okay, well, there's a little tricky aspect to this. Well, I'll tell you the answer, but here's the thing. Technically, if it were sideways, it wouldn't be a function. The idea of functions are that there is only one y for every x that's on your graph. So technically, it wouldn't be called a function, but we're going to, of course, ignore that. We'll just say, what would the equation look like? So the nature of our graphs, here's what you have to understand. Absolute value functions v-shape the way that they do because of the nature of absolute values. When we take the absolute value of something, we get, I guess you can say, its positive result out. So when I take the absolute value of 3, I get 3. When I take the absolute value of -3, I get 3. X is my input in this case, and I go left and right when I plug in the input, and my output is the thing that gets absolute valued, right? The input goes into the absolute value, but the output is what happens after the absolute value occurs. That's why we get a right side up or upside down, because if we take the absolute value of something and then make it negative automatically, it goes straight down. So how do we go sideways? You would have to make y become your independent variable and x become your dependent variable. So now it's based on plugging in a y. When y is 3, the absolute value of 3 is 3. When y is -3, the absolute value of -3 is 3. And it goes like that. So it's no longer a function, so I can't use f of x here. In fact, I wouldn't, because it would be more of a function of y. But instead of my equation being some y equals a times the absolute value of x minus h plus k, and this isn't going to be perfect, so I'm going to use different letters, I would use an x. X equals, I'll say b, as a horizontal stretch factor. B times the absolute value of y minus k plus h. There you go. That's how you do it. So if I wanted to have a graph that would have a horizontal stretch factor, here, I'm going to use some of the numbers I used before. Horizontal stretch factor of 3, a vertical shift of 7, and a horizontal shift of 2. Like that. That's what would happen. So what would this graph look like here? This graph, I'll pull out a graph thing. This graph would start at the point, now you flip keep, but this time 2 is your horizontal shift. So you'd go 2, 7, like that, 2, 7, and you would run 3, fall 1, and run 3, rise 1, like that. So that's what this graph would look like here. You could try it on a graphing calculator or something like that. That's what you get. But that's because x and y swapped. Now that's not a function anymore, and we're not really doing those because we're only graphing absolute value functions. It's possible to make, but that's what it'd be. It's dependent now on x is now dependent on y instead of y being dependent on x. So anyway, I kind of wrote an equation format there. Let me get it back. Looks like that. There you go. Hopefully that kind of answers it. Kind of interesting question. I like how you're like creative in thinking about that stuff. It's kind of nice. I like seeing those things. All right, 1 second. Okay, next question here. 2 more. When solving an absolute value equation, can you create a condition before isolating the absolute value quantity? I wouldn't at all. So their question that they're asking is, when I use the phrase condition or the term condition to my students, what I'm talking about is conditionally, what kinds of things can you put into here? If you put this thing in here, what would come out? Or should I say, if this comes out conditionally, what could be put in here? what we're talking about when we go from the part where we have the isolated absolute value quantity with the bars to the no bars, when we split the arrows up and say either equals this or this, that's because now we're looking inside the absolute value. We're asking, what can we take the absolute value of? So no, I wouldn't, because the dangerous aspect of it that you're not thinking about, there are times that you can, but I still wouldn't anyway. The dangerous aspects that you're not thinking about are, what if I gotta move a term over by dividing or subtracting or doing something like that, and suddenly my constant on the other side turns negative instead of positive? We're talking about what we have to take the absolute value of. Right? That's the condition. What we have to take the absolute value of to make something happen. The only times that I would ever consider doing it for myself, and I still wouldn't, but the only times I would ever consider doing it for myself are when you have something like this. Obviously there are different things I could write inside here, but where you have a positive stretch factor outside of here, because no matter what happens when you divide by a positive, you still get the same sign result here, because this and this are technically the exact same thing. We've learned that, let me kind of flip this, we've learned that the absolute value of a product equals the product of two absolute values, and we know that the absolute value of a positive is still a positive, so we still get that out. So this is the only time that you could still say either 2x equals 20 or 2x equals negative 20 and not have any sort of issues with it. Otherwise, if you have to add or subtract something, you got to move it over first, because you got to get the positive or negative. So this is the only time. So literally, I'm just going to say no. No, you can't. Isolate the absolute value quantity. The whole idea of it is we're looking inside the absolute value to make it happen. Sorry that I'm answering these longer than I need to, but I really want to make sure that makes sense. Thanks for asking. It's a dangerous implication if we do it wrong, so I really wanted to explain it. And finally, the last question asks, how do we do a problem with the absolute value in parentheses? So to be clear, you're saying the absolute value is in parentheses and not parentheses inside the absolute value, because we've seen that. I guess, there was a homework problem. It's on my solution guide video. I skipped it for my class just for the time being to get, I think, 10 questions in. Let's go ahead and do one of the ones that I think they're asking me about. What they're saying is, if you have some sort of, I've been using that 3 thing, right? So let's do 3 times the parentheses, absolute value of x minus 7 and then plus 2. I want this to come out cleanly here. So let's say equals 21. Equals 21 here. So how do you do it with an absolute value inside parentheses? You have one of two options, whether you'd like to distribute the 3 first, or if you recognize that because 3 is a product of this entire quantity here, you could divide both sides by 3 first. I don't know if people would quite understand the dividing by 3 here without kind of messing it up in times when you're not supposed to. So I'm going to speak more in terms of distribution, at least for you to make sense of what I would do next with the distribution. And I'm going to do more with my students with this stuff as well, but I wanted to do one step at a time. Now, when I distribute here, the only thing that you just got to be careful of is, here's a quantity and here's a term. I'm going to multiply 3 by the whole thing. So I'm going to write it as 3 times the absolute value of x minus 7 plus 3 times 2, like that. So that will help take care of what it is that we're trying to do there. That's how you would do it. You would distribute, and I'm not going to keep going on it, but you would distribute it in such a way, because I don't want to distribute the 3 into the absolute value in and of itself, right? I want to keep that protected for all intents and purposes. But I'm distributing it into the quantity, into the thing that would represent its own separate term, such as 2 does right there. Distribute and make that happen. Subtract 6 from both sides, divide both sides by 3, create your 2 conditions where you solve for x, and that would be it. So I hope that makes sense as far as what you're supposed to do with it. Distribution there. You could, like I said, you could divide both sides by 3, and if I did this instead, divide both sides by 3 like that, I would get absolute value of x minus 7 plus 2 equals 7, and you keep going. You would solve it that way. This is faster and better if you recognize what to do then and not to mess up at a different time. All right, so that was the last question there. Thank you so much for asking those, guys. That ought to do it for this one for Mr. Robinson's Q&A Power Half Hour. Power Half Hour there. Boom, boom. Thank you so much. And if you have any more questions you'd like to ask students, please keep submitting in the Power Hour. I hope this was useful for you. Thank you, and take care.